find the derivative for arcsine and arccosine. So in this video, we're going to be talking about how to take the derivatives of our inverse trig functions, starting with the inverse of sine and the inverse of cosine. Alright, so up here we want to take the derivative of inverse sine and inverse cosine. And now the inverses of these particular functions are a little bit unusual because they're going to look a lot different than what we started with. So the derivative of sine inverse of u is going to be 1 over the square root of 1 minus u squared. So again, this is a little bit odd, probably not what we expected, but this is the derivative. So again, when we want to take the derivative of inverse sine of u, we're going to get 1 over the square root of 1 minus u squared. However, if u is a function, or if we do require the chain rule here, remember we are going to have to then multiply this fraction by u prime. Now moving on to the derivative of inverse cosine, it's going to be very similar. The only difference is that we're going to have a negative in front of it. So inverse cosine is equal to negative 1 over the square root of 1 minus u squared. And again, if we do need to use the chain rule, we will have to multiply by u prime. Now, both these equations do have a condition placed on them, because remember, with sine of u, the input of u is really the output of our normal sine function. And if we remember back to pre-calculus, the output of our normal sine function is from -1 to +1, which means the input of our inverse trig function is also -1 to +1. Now, this is a condition for inverse sine of u. However, this is not one that we necessarily need to worry about in Calc 1. If you are moving on to Calc 2 or higher level mathematics, this will become more important, but in this class, that's not too important. It's just a good note to make. And the same is true for inverse cosine. We know that this u represents the output of our cosine function, so therefore the u also has to be in between -1 and +1. So these are our two derivatives. However, if we think back to calculus, we did also have alternative notation for inverse sine and inverse cosine, and that would be the arc notation. And since arcsine and arccosine are the same thing as inverse sine and inverse cosine, they're just going to equal the same formulas. But I did want to put them up here just because you will come across both of these notations in this course, and you just need to remember that they both represent the same thing, and therefore they both have the same derivative formula. Alright, so in our first example, we're being asked to find the derivative of 3 sine inverse of x. So before we dive into this, let's just do a little bit of side work here and a little bit of thinking through, since this is our first derivative of an inverse trig function. Well, we know that the derivative of sine inverse of u is going to be 1 over the square root of 1 minus u squared, and then times the derivative of u. So the first thing we should be thinking about is what does our u represent in this function, or what is the function inside of sine? And as we can see, the function inside of inverse sine is going to be x. So we can then say that u will be x, and then u prime is just going to be 1, because the derivative of x is 1. So now we can go ahead and we can apply our formula to this derivative, but before we do that, we know that we have a property that allows us to factor a coefficient out of a derivative. So that's the first thing we're going to do, is we're just going to factor the 3 out of the derivative. And then from here, we can apply our formula. So since the 3 is outside of the derivative, we are going to leave the 3 alone. And then we can take the derivative of inverse sine. And we know that that's going to be 1 over the square root of 1 minus u squared. And remember, we said that u is equal to x. So instead of substituting in u, we're going to substitute in x. So we'll get x squared times, then we need to multiply this by the derivative of u. And again, we've already determined the derivative of u is 1. So now we can just multiply this by 1. And we know that 1 times anything is just going to be that thing. So that means we're going to be left with 1 over the radical of 1 minus x squared. And then from here we need to simplify. And we know that when we multiply a whole number by a fraction, we're just going to multiply the whole number by the numerator of that fraction. So that is going to give us a final derivative of 3 over the square root of 1 minus x squared. And there we have it, the derivative of 3 inverse sine of x. All right, moving on. Now we want to find the derivative of inverse cosine of x to the 4th power. So again, we're just going to do a little bit of side work here before we dive in, because we know that the derivative of inverse cosine of u is going to be negative 1 over the square root of 1 minus u squared times u prime. Because again, the only difference between inverse sine and inverse cosine is that negative in front. Next up, we need to identify what our inside function is, or what's the u. And we can see the function inside a cosine is x to the 4th. And then we'll take the derivative of this to get u prime, and we can see that u prime is equal to 4x cubed. Now we have everything we need, so we can go ahead and take the derivative. So we said the derivative of inverse cosine is negative 1 over the square root of 1 minus u. But again, we said that u is going to be x to the 4th. So we're going to have 1 minus x to the 4th squared, and then times u prime, which is 4x cubed. And then we can continue to simplify this down. As we stated in the last example, when we're multiplying a fraction by kind of a whole number or by an expression, we can just multiply that whole number to the numerator. So that's going to give us negative 4x cubed over the square root of 1 minus, and x to the 4th squared. Remember, when we take the power of a power, we're going to multiply those powers, so we're going to end up with x to the 8th. So therefore, our derivative is going to be negative 4x cubed over the square root of 1 minus x to the 8th. All right, next up, we want to take the derivative of arcsine of x squared minus 1. And remember, arcsine is the same thing as inverse sine, so we can use our formula. However, now since we've done a couple of these, we're going to try to solve these without doing that side work. Because while that side work is great when we're beginning, it's just going to take up too much time once we've learned the material. So our goal is to have that formula and that work internalized, so we can just go ahead and solve it. So that's what we're going to try to do here. So, if we want to take the derivative of arcsine, we know the derivative of arcsine is going to be 1 over the square root of 1 minus our inside squared times the derivative of our inside. And we can see that the inside function here, or we can see that the inner function is x squared minus 1. And then using chain rule, we have to multiply by the derivative of that. And the derivative of x squared minus 1 is x squared. And then we can continue to simplify. We know that we can multiply that x squared to the numerator. So that's going to give us x squared over the square root of 1 minus. And then we come to the quantity x squared minus 1 squared. Now, folks love to do this, and is 100% absolutely wrong, so please don't fall into this trap. A lot of students like to do, oh, x squared minus 1 squared, that's just going to be x squared squared minus 1 squared. And that is 100% absolutely wrong! That's not what squareds mean! Squareds mean we take the base and multiply it by itself. So really, x squared minus 1 is going to be x squared minus 1 times x squared minus 1, because that's where the squared comes from. So we can substitute that in, x squared minus 1 times x squared minus 1. And then we can FOIL that guy out. So we're going to have x squared over the square root of 1 minus the quantity x to the 4th minus x squared plus 1. And we can continue to simplify this down, x squared over the square root of 1 minus x to the 4th minus 2x squared plus 1. We can then take the negative and distribute it through, which is going to give us x squared over the square root of 1 minus x to the 4th plus 2x squared minus 1. From here we can see the positive 1 and the negative 1 cancel out, which leaves us with our final simplified derivative of x squared over the square root of negative x to the 4th plus 2x squared. Boom, derivative. All right, our next example is the derivative of the quantity arcsine of x raised to the 5th power. So here we can see that we have an inverse trig function inside of an exponent, which means ding, 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 chain rule. So we can see that here our inside function is arcsine of x, and we can see that our outer function is to the 5th power. So chain rule says we take the derivative of the outside function first, which means we'd have 5 times the quantity raised to the 4th power. We're then going to throw the inside back inside, and then we're going to have to multiply by the derivative of the inside. And that's where today's lesson comes into play. Because what is the derivative of arcsine of x? Well, we can see here that in this particular case, x is our u value. U is equal to x, so that means u prime will be equal to 1. So therefore our derivative is going to be 1 over the square root of 1 minus x squared times 1. And then we can continue to simplify this down. So let's see, we are going to have 5 times arcsine of x raised to the 4th power times 1 over the square root of 1 minus x squared. And then we can multiply the 5 arcsine of x to the 4th power to the numerator, giving us our final simplified derivative of 5 arcsine of x to the 4th power all over the square root of 1 minus x squared. Boom, boom, boom. Done. All right, next up. Interesting. This time we want to take the derivative of a cosine of sine inverse of x. So we have an inverse trig function embedded in another trig function. Crazy. But this does mean we're going to have to use the chain rule. Sine inverse is the inner function, and cosine is the outer function. Chain rule says we take the derivative of the outer function first, and the derivative of cosine is going to be negative sine of the inside. And we're going to put the inside back in, so sine inverse of x. And then we're going to multiply by the derivative of sine inverse of x. And again, we can see here that our u value is going to be x, which means our u prime will be 1. So our derivative will be 1 over the square root of 1 minus x squared times 1. All right, now it's time to simplify this down. And wouldn't you know it, we have sine of inverse sine. So sine of inverse sine. And we know that those two items are going to cancel out, which is just going to leave us with negative x times 1 over the square root of 1 minus x squared. And again, we know that 1 times anything just becomes itself. Well, then we can continue to simplify by multiplying the x to the top. And that is going to give us a final derivative of negative x over the square root of 1 minus x squared. And then our final example, we want to find the derivative of x to the 9th times arccosine of x. And this one is multiplication, which means we get to use the product rule. Woo! All right, so x to the 9th is our first function. Arccosine is our second function. Product rule says we take the derivative of the first function, which is 9x to the 8th. We leave the second function alone, arccosine of x. And then product rule is always, 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 always plus. Then we're going to leave the first function alone, x to the 9th, and then we need to multiply by the derivative of arccosine. Now with arccosine, we can see that our u value will be x, and our u prime then will be 1. So when we take the derivative, we're going to have negative 1 over the square root of 1 minus x squared times 1. Now we just need to simplify the second term a little bit more. So let's see, we are going to get 9x to the 8th arccosine of x minus x to the 9th all over the square root of 1 minus x squared. And I got that by taking the x to the 9th and multiplying it by the numerator. I know that 1 times anything is just going to be itself, and the plus turned to a minus because of this negative. And there we have it. The derivative of x to the 9th arccosine of x. Alright folks, that is it. That is finding the derivative of arcsine or arccosine functions.